All right. There was one problem yesterday that I wanted to get to that we didn't have time for. So I was going to kind of start today with that, and that kind of leads into some of the things that we're going to talk about today. We're still going to be doing polynomials, but now we're going to talk about the types of zeros that we could have, how many zeros, and what type they're going to be. And so there's going to be a lot of different types of polynomials. And so I'm going to give you an example, and we did one kind of like this yesterday. All right, so we did one like this yesterday, and we talked about how right now it's not in factored form, so we want to put it in factored form. And so what we're going to look at is product and sum would work here, but it's going to be a little bit different than the one we did yesterday. So if I look for what multiplies to get negative 45 and adds to get 4, we would get a positive 9 and a negative 5. Okay. And the directions on something like this are going to ask you to solve, but then we're going to usually write our answers in exact form and not decimal form. And we're going to solve it by hand first, and then I'm going to show you what the graph looks like, and that's going to kind of lead into what we're going to talk about today. So we got to solve both of these for x. And so kind of like what we did yesterday, we're going to set both of these equal to x, or equal to 0, and we're going to solve for x. And because there's no x in the middle, then this is the square root method. Okay? And we did one like this one here yesterday when we did x squared minus 5. I would add 5. I would take the square root, and I get x equals plus or minus the square root of 5. Okay, so that one's pretty straightforward. We got an answer kind of like that yesterday. The one on the left, I'm going to subtract 9, and I'm going to take the square root. And what's going to happen here? It's going to, because we're taking the square root of a negative, we're going to get 2 imaginary solutions. Okay? So imaginary solutions aren't going to go away, unfortunately. We're going to continue to see. And we didn't have any yesterday that had imaginary solutions, but I just wanted to show you that this is a possibility. And this is something that we will continue to see as we go throughout chapter 4. So I just wanted to kind of introduce this. Now, if I graph this, okay, I want to show you what the graph's going to look like, and then, like I said, that's going to lead into what we're going to talk about today. If we graph this one, let's just go ahead and type this into our calculator. So one thing that I want to kind of go through here is if I have a quartic polynomial, there are 4 zeros that we have to account for. And there's a lot of different ways that can happen, okay? For instance, a real easy one, we saw this yesterday, might look something like this. And it's kind of a W-shaped type graph in most cases. But if it has 4 zeros, then that one would be pretty straightforward. It crosses the x-axis 4 times, and so that one's pretty easy to determine that those are my 4 zeros. Wherever it crosses the x-axis are my zeros. If we go back to another one that we saw yesterday, here would be another possibility. This one only crosses it twice, and then we talked about this bouncer right here, where it comes down, hits, and comes right back up. So it only touches the x-axis in 3 different places. And so here we have 3 different zeros, but we say that this one is a multiplicity of 2 because it comes in and it leaves from the same spot. So this kind of counts as 2 zeros right here, which still accounts for our 4 zeros total. Okay, so we got 1, 2, and this counts as 2. The one that we just talked about basically it's the same type of graph again. If I see something like this, it crosses the x-axis twice, but then it never hits or touches ever again. And so because this hump never comes back down and touches the x-axis, then this one would have two real zeros, and then the other zeros are imaginary. Okay? So when I have 4 zeros, there's a lot of different possibilities here, right? That doesn't mean the graph has to cross the x-axis 4 times. So like for instance, this one, we would say that it has 4 real zeros. This one has 3 real zeros, because one of them is a multiplicity of 2, and it counts as 2. This one has 2 real and 2 imaginary zeros. All of them are quartic polynomials. Essentially the same type of graph. Looks a little bit different, but they're still quartic. Okay? And so as we go throughout this chapter, what we're going to have to determine is, what are my zeros going to be? And what type of zeros are we going to have? Today we're going to just focus on the graphing of these polynomials. And so it's still good to know that your graphs are going to look a little bit different based on what type of polynomial I have. But we're just going to kind of focus on some of the important parts of graphing this and what makes it special or different. We kind of did that with quadratics in the last chapter, where we, that I just put up here. This was a quartic, examples of quartic polynomials. So we had a degree of 4. So turning points is where it changes direction. So this would be 1, 2, 3 turning points. Okay. Same thing here. 1, 2, 3 turning points. 1, 2, 3. It doesn't have to have 3 turning points, but that's the most that it could have. Can't have more than that. And in most cases, that's probably the number of turning points that it could have, but it doesn't have to have that many as well. And so if I had think about like a quadratic, right? If I had a quadratic, we know it makes a parabola. How many turning points does it have? Well, it only has 1, right? Either the minimum or the maximum, depending on what direction it opens. So the vertex is that turning point of a parabola. And so it even ties into the things that we did in the last chapter when we did the graphing. So that's going to be something that we're going to kind of look at today. Okay, some of the things that we're going to look for when we graph polynomials. I'm just going to list out some different steps of some common things that we want to pay attention to. Kind of like when we did graphing polynomial or parabolas last chapter, we wanted to find the vertex. We wanted to find some points on either side of the vertex. We wanted to find some key parts of that graph. Since today our main focus is graphing, we want to be pretty exact about the points that we use, the graph that we're graphing. Sometimes we just graph a sketch. We just want a real basic look at what the graph looks like, which is kind of what I was doing on the previous ones. But when it says graph the polynomial, we want to be pretty particular about our points that we're using, where the vertex point's going to be at, and then some different things that we're going to be looking at. Okay, one of the things that you can do today is what we talked about yesterday, the leading term test. And what that does is that tells us the end behavior of the graph. Is it going to go up, up? Is it going to go down, down? Is it going to start up and end, down? What is the end of the graph going to look like on both ends? Okay, another thing we want to pay attention to is the zeros of the function, otherwise known as the x-intercepts. Where does it cross the x-axis at? The y-intercept. In order to find the y-intercept, I could plug 0 into the function, and I could find out where it crosses the y-axis at. You can do it off the graph as well, but if you wanted to do it algebraically, and sometimes algebraically might be a little bit easier depending on what the graph is, I just plug 0 in for x and I find out what my y value is, and that's where it would cross the y-axis at. Okay, and then we would look for some additional values. Those additional values might be the relative max or the relative min. Towards the end of the lesson yesterday, we didn't really spend a lot of time with it, but we've done that before. If we're doing like a relative min and max, especially if it was like a cubic function, then we might have a graph that looks like this. This right here would be the minimum. This right here would be the relative maximum. So those would be a couple of key points that we would want to try to get, like where is it changing or turning directions at. Okay, and then finally, we're going to take all of that information, we're going to put it together in order to graph it. Okay, we want all of that information to tie together to help us graph a picture of the graph. And the reason I tell you all of this is because I know that you can put this into your calculator today. Okay, and as I've told you over and over again, I don't have a problem with you putting it into the calculator, but the biggest thing, like on a quiz or a test, in this chapter especially, is take the information that we get from the calculator and be able to put it onto a graph, right? Get that particular information. Don't just slap a graph up there and say, there it is. That's what it looks like in my calculator. We want to know, where is the minimum maximum at? Where is it crossing the x-axis at? Where is it crossing the y-axis at? We're trying to get all of that information. So those are some key points that we would want as we graph it. Okay, so there's a big difference between when it says graph and if it just says sketch. Sketch a graph doesn't mean we're looking at anything real particular. We're just wanting kind of a quick glimpse of the graph. If we're actually graphing it and that's the problem we're doing, we want some particular information. All right, so there's only 2 examples today, but we're going to kind of walk through these steps, and one of them is going to be in factored form, like we saw yesterday, and one of them is going to be in standard form. And when we graphed it yesterday a little bit, just to kind of show you what the graph looked like, today we're going to take it a little bit further and find out some of these things. Okay, the format that a lot of polynomials are written in is standard form. In standard form, if we walk through these steps here, yesterday we talked about the leading term test. Make sure it's in highest to lowest from the exponents, which it already is. So 3 is my degree. It has a degree of 3, which is odd, and it has a positive leading coefficient. So here we would say it has a degree of 3. And because the 2 is positive, that means the graph is going to start down and it's going to end up. That's that chart that we talked about yesterday. If this was a negative 2, then it would start up and it would end down. It would have just the opposite relationship. Because it has a degree of 3, it could cross the x-axis 3 times. At most. That's the thing that we talked about at the very beginning of the lesson. Just knowing how many times could this cross. And like I said, it doesn't mean that it will cross it 3 times, but that's the most that it could cross. Okay, the next thing is finding the zeros. We did one like this yesterday. We have 4 terms, and we're going to do this algebraically. Can you use your calculator? Absolutely, but sometimes those zeros are not nice whole numbers, right? And so we want to try to get like, what are the actual zeros of this? That'll help you as you go throughout this chapter as well, because a lot of times we're going to be looking for the exact zeros of this polynomial. Sometimes they end up being nice whole numbers, sometimes they don't. And so when we did this one yesterday, because this is 4 terms, we're going to break this up into 2 groups of 2. We call it grouping. Out of the first group, we can take out an x squared. And that leaves me 2x plus 1. When we take x squared out, what I'm really doing is I'm taking these 2 terms and dividing by x squared, because that's my GCF. So 2x cubed divided by x squared just leaves me a 2x. Probably the thing that gets missed or left off the most is if I take x squared divided by x squared, then I still have to put a 1 there. A lot of people just don't put anything there. But we're dividing it out. And so when I divide it out, we do have to put a 1 in that place. Out of the second parenthesis, I could take out a -4. -8 divided by -4 would be 2x. -4 divided by -4 would be positive 1. Okay. And what we said yesterday is we want these 2 sets of parentheses to be the same. If we've done everything right, if it works out right, that's the way it should be. There are times where that may not work out like that. So then we're going to have x squared minus 4. We're going to combine the outside parts together. We're going to have 2x plus 1. Kind of saw this yesterday. X squared minus 4 is DOPS. Okay, so this right here, if it ever asks you what is the factored form of the polynomial, this would be the factored form. Okay, and we're not necessarily doing that a lot today, but we did see that yesterday. If I multiplied these 3 binomials back together, it would get me back to that original polynomial that we started with. Okay, but the factors help me to find the zeros. So to find the zeros, we're going to do x plus 2 equals 0, x minus 2 equals 0, 2x plus 1 equals 0. So we're going to get x equals -2, x equals positive 2. And on this last one, it's a 2-step equation, okay? So we're going to subtract 1 and we're going to divide by 2. I'm just going to kind of combine those into one step here. So I'm going to subtract 1 and then I divide by 2 would just give me -1/2. Okay, so those are the 3 places that this would cross the x-axis. It's kind of up to you how you want to do your graph. I think in some cases it helps to kind of, as you get information, kind of put it on your graph. So we have -2, we have positive 2, and then we have -1/2, which is between 0 and -1. Okay, we also know that this graph is going to start down and end up. So it's going to start probably down here somewhere, it's going to end up here somewhere, but we don't know the kind of path of the graph yet, so we can't do anything with that. Step 3. We're going to plug 0 in for x. We're going to find the y-intercept. Okay, and like I said earlier, you can do this in your calculator. There's nothing wrong with doing this in your calculator, but when I plug 0 in for x, it should be a piece of cake. And there's a little trick here. If I plug 0 in here, 0 cubed times 2 is still 0. 0 squared, still 0. 8 times 0, still 0, right? So 0 plus 0 minus 0 is all 0. 0 minus 4 is -4. So that end value, that constant value there at the end, is always your y-intercept. if it's in standard form. So my y-intercept is -4. When I plug in 0, I get -4. And so that's where this graph is going to hit the y-axis at. Okay? Understanding why and where it all comes from. Okay? We already talked about how it should have 3 zeros. Where does it reach its relative min and max? That's not something that we're probably going to do by hand. We're probably going to use our calculator to kind of come up with that. So we're about ready to put this into our calculator and kind of get all this information. Okay? And I get it. Like our first instinct is I want to just put this in my calculator, graph it, and be done. And can you get a lot of this information from your calculator? Sure. But you just got to be careful of what kind of zeros do I have. Sometimes those zeros are not going to be really easily obtained from your graph. Okay, so let's put this into our calculator now. We're just going to put it in just like this. 2x cubed plus x squared minus 8x minus 4. Oh, I wrote that down wrong. Put it in the wrong spot. That's going to be my maximum. My minimum is 1 - 9. Okay, and once again, if you want to, I mean, you can always use a piece of graph paper if you want to, but we're just going to kind of approximate where these are because they're not always nice whole numbers. But that's one of the reasons why we talked about the minimum and maximum yesterday is we're going to continue using those. And then the last thing we're going to do is we're just going to connect all of these things together to kind of make our graph. So as we put this together, we're starting down here. This is where we're going to turn. We're coming back down through the x-axis. We've got to go through the y-axis at -4. We're going to come down to this minimum. We're going to turn again and then come back up through that x-intercept. Okay. So we're just tying all that information together to kind of get a better idea of where the graph would be. Do you need other points? Probably not. You know, like when we did parabolas, we looked for other points. All of these things right here should be enough, right? I mean, if you want to get more points, you can simply go to your table of values in your calculator and you can get more points if you want to. But these points that we came up with give us a pretty good sketch of our graph and give us a pretty good look of everything that we need. Okay? And there's never, it's never wrong to do more, right? But this would probably be enough. Okay. Any questions on any of that? Okay, so that's standard form, okay? The second one, there's good and bad to each one. We kind of talked about that yesterday when we did our solving. Factoring, if it's already in factored form, solving it's a piece of cake, right? But doing some of the other things aren't quite as easy. And so that's why we're only doing 2 examples. One's going to be in standard form. The other one here is going to be in factored form. Okay, so there's good and bad to each one. The bad to this one is when I look at it, I don't necessarily know what my degree is immediately. Okay, and knowing the degree is really pretty important. Okay, if I wanted to know what the degree of this polynomial is, anybody want to guess what the degree of this polynomial would be? 4. Okay, how come?
Because the 2 squared, and then you add the other 2 on.
That's exactly right. This has 1. This would be x squared, and this would be x to the fourth. So 1, 2, and 1 would make. If we multiply all of those together, and that's really what's going to happen as we go from factored form to standard form, we would multiply all of these factors together, and that would give us our standard form polynomial. Okay, and we're not going to do that. We don't really need the standard form, but understanding that if I multiplied all these together, x to the first, x squared, and x to the first, we add all those exponents together, that would give me x to the fourth. So this one's going to have a degree of 4. So it's a quartic polynomial. It has a degree of 4. There is no leading coefficient. There's nothing out in front of any of the x's. So that means my leading coefficient is just a positive 1. And so it has an even degree with a positive coefficient. And so this graph is going to start up and it's going to finish up. So that's one of the harder things to kind of get from, and it's not necessarily difficult once you understand that you got to multiply all those together to get your degree, but just understanding kind of what the graph's going to look like. Okay, getting the zeros is pretty easy here. All we have to do is set these equal to 0 because it's already in factored form. So this would be x equals -1. This would be x equals 2. This would be x equals 4. Okay, and one other thing that I'm going to add to this is what we talked about yesterday. This has a multiplicity of 2. And that's a really important piece of this graph to kind of understand what's going to happen at that point. Because it was a degree of 4, we said that it could touch or cross the x-axis 4 times, right? But what's going to happen in this one, it's only going to touch the x-axis 3 times. It's going to touch it at -1, +2, and +4. And what we said yesterday is if it has an even multiplicity, it's going to bounce off the x-axis at that point. Okay? And that's my words. You'll never see the book use the word bounce, but I think it just, visually for me, that's what makes the most sense. It's going to hit the x-axis and bounce right back off. Okay? These two have a multiplicity of 1 because there's no exponent, so it's assumed to be 1. So at these two, it's going to go through the x-axis at those 2 points. So knowing what's going to happen at those points is kind of important, I think. Also knowing that it's not going to cross the x-axis 4 times because it has a degree of 4 is an important thing to keep in mind. Okay, and so now let's do the y-intercept. And you could do this off of your calculator. But we're going to take 0 and plug it in. This one's not quite as easy as the last one. There's some things that are good, some things that are not so good. When I take 0 and plug it in here, 0 plus 1 is 1. 0 minus 2 is -2, but then I got to square it, which is 4. And then 0 minus 4 is -4. So we have 1 times 4, which is 4. 4 times -4 is -16. So my y-intercept is going to be all the way down at -16. 0, -16. Okay. And I'm not going to count all the way down there, but I'm just going to label that as -16. Okay, then the last thing that we need to do is we need to come up with the minimum and maximum. You can totally do that off your calculator, and then we're going to draw ourselves a sketch. Okay, so let's go to our calculator then. And we can type this in just like this. There's no reason to try to multiply it all out and get it in standard form. Factored form works. Okay. And then I'm just going to kind of use all that to graph it. So we're going to start up. And draw a sketch kind of looks like that. I didn't put the values in here, but you can get those off your calculator and identify what those points are if we have to, and then just use that to kind of sketch where those would be. One thing I did not point out on the last one is we said this one is going to start up and end up, and sure enough, that's what it does, right? It starts up here and it ends up here. So that is my end behavior. That's what the leading term test tells us. There's going to be some graphs that are really hard to tell what that end behavior is, and that's why we use that leading term test. But it works for any polynomial to tell us what the graph's going to look like at the end. Okay, so I think factored form is probably a little bit easier. Getting the zeros is definitely easier. There's a few things on there that make it a little bit more work. But if we have one like that on our quiz next week, then those would be some of the key points that we're going to be kind of looking for. And I'll kind of remind you of all that, of what I'm looking for on the ones that we're going to graph. Okay, all of these are just graphing. The directions say follow the steps outlined in the procedure. The procedure they put in the book is a little bit different than the procedure that I use. I don't have quite as many steps as the book has. I just kind of limited it to some of the most important things. So you don't have to go back and look at their steps. Just go off of what the steps that we listed and just find those key points. But they're all graphing problems. Found like what's the minimum, maximum, what's the x-intercepts or the zeros, and we found some of those important parts of the graph. And that's kind of what we're going to do today, but we're going to do it with different types of polynomials. All right, so that is what we're going to do today is 4.2 is graphing polynomials. Okay, P of x is a polynomial of degree n, okay? Now, what does that mean? Well, if I wrote a polynomial, and I'm putting this in red so we know what's going on here. The highest exponent, if it's in standard form, is the degree, and that degree is going to tell me a lot of different things about the graph. Okay, so we're assuming that this polynomial is in standard form, and I didn't really write like this big old nasty polynomial here because it's going to just be something that has some type of degree, and then it's going to have maybe not have a constant at the end. So we don't really care what the rest of that polynomial is if we're just focused on the degree. So what this means is it will have at most in real zeros. So if I have a degree of 4, it could cross the x-axis up to 4 times. If I have a degree of 3, it could cross the x-axis up to 3 times, right? So the degree tells me how many times it could cross the x-axis. And that's why I showed you all those 3 different graphs. Is they're all quartic graphs, right? But they all had a little bit different scenario as far as how many zeros it was going to have. So degree of 4, 4 is the most. If you have a degree of 4, you can't have 5 zeros, basically. Okay, so that's the first thing. At most, in real zeros. At most, in x-intercepts, which are essentially the same thing. X-intercepts talks about an actual point on the graph. Zeros is what makes that function equal to 0. But they're the same thing. They're correlated to one another. We just have a little bit different name or terminology for them. And then the last one is it will have n minus 1 turning points. So the most turning points it can have is 1 less than the degree. If we go back and look at the 3 graphs,